Your boarding pass says your flight departs at 6:30 p.m. The airport display also says it is on time, but the flight has not arrived, the gate is still occupied, boarding has not started, and one of the operational feeds has not updated for 20 minutes. So is the flight really on time? And which answer should you trust? This may look like a flight status problem, it is actually an enterprise data architecture problem. Hi, I am Anil. Welcome to the Trusted Data Architect channel, where we use realistic enterprise stories to explore how trusted data platforms are designed. In Project SourceTRU, we are designing a trusted enterprise data intelligence platform that combines fragmented operational signals to provide a clear, explainable estimate of when a flight is likely to depart. The airport story keeps the problem relatable, however, the real subject is architecture. Integration, shared meaning, data quality, access control, observability, resiliency, and decision intelligence. A passenger sees one flight number and one scheduled time. Behind that answer are multiple organizations and systems. The airline may own the commercial schedule, boarding progress, and its official estimate. The airport may own gates, stands, and movement information. Ground service providers may know whether cleaning, catering, fuel, and baggage activities are complete. External sources may provide weather and airport congestion signals. Each system sees part of the situation. Each updates on its own timeline. No single system necessarily holds the complete truth. A common enterprise mistake is to treat integration as the goal. Connect the feeds, load a database, build a dashboard, and assume the answer is trusted. But the integrated data can still be late, duplicated, incomplete, inconsistent, or incorrectly matched. Imagine the airline feed says gate 12 while the airport system says gate 15. The platform must understand which source is authoritative for that attribute, when each update became effective, whether one message is a correction, and whether either feed is stale. This is why Project SourceTRU is not simply an integration platform. It must create governed intelligence from evidence. For Project SourceTRU, trust has several dimensions. First, source. Where did the information come from? And what is that source authorized to assert? Second, freshness. Is the information current enough for the decision? Third, completeness. Do we have the evidence required to make the claim? Fourth, consistency. Do the sources agree? If not, how is the conflict resolved? Fifth, lineage. Can we trace the answer back to the events, rules, and versions that created it? And sixth, access. Is the viewer permitted to see this level of operational detail? Trust is not one feature. It is an architectural quality that must exist across the platform. At a high level, Project SourceTRU contains 7 layers. The source ecosystem includes airport, airline, gate, baggage, ground service, and external systems. The data exchange layer receives files, APIs, and events and manages contracts, acknowledgements, and reply. The trust layer validates schemas, removes duplicates, measures freshness, quarantines invalid data, and evaluates quality. The harmonization layer creates common identities and definitions and reconciles conflicting evidence. The intelligence layer constructs a trusted flight state and calculates the expected departure, confidence, and explanation. The data product layer publishes owned, governed, and supported outputs. And the consumption layer provides appropriate views to passengers, airlines, airport operations, and service partners. Across all 7 layers sit metadata, lineage, access control, audit, observability, resiliency, and cost management. Project SourceTRU should not present only one time. It should distinguish the original schedule, the official estimate published by the responsible operator, and its own evidence-based expected departure estimate. It should also show the current flight stage, the confidence in the estimate, the evidence behind it, and the time of the last trustworthy update. For example, expected departure 7:05 p.m. Scheduled departure 6:30 p.m. Confidence high. The inbound aircraft arrived 22 minutes late, cleaning is complete, and boarding has not started. The useful product is not the number alone. It is the number together with evidence, context, and limitations. It may be tempting to begin with machine learning, But a predictive model cannot compensate for inconsistent identities, stale feeds, unclear ownership, or missing lineage. The first version of Project SourceTRU should use transparent rules: inbound arrival plus expected turnaround, completion of required activities, gate availability, boarding progress, and known constraints. Once the platform has trusted historical data, prediction can become more sophisticated. The architecture foundation comes first. During season 1, we will map the system landscape, design the platform layers, create a trusted current state model, define data quality and access controls, design the expected departure capability, and finish with an implementation roadmap. This is not an airport tutorial. The same problem exists whenever enterprise truth is distributed across systems and organizations in finance, healthcare, logistics, utilities, retail, or government. The executive lesson is simple. A trusted answer does not come from choosing one database or one source system. It comes from designing how evidence, ownership, controls, and products work together. In the next episode, we will examine why no single system holds the complete truth and map the organizational and system boundaries behind Project SourceTRU. Project SourceTRU is a fictional scenario, but the architecture challenge is very real. Subscribe to the Trusted Data Architect channel to follow the platform as we develop it one architecture decision at a time. Thank you.